Hello and welcome back to Cretitas Math. So this is the fifth video in the SN Prep video series. This is what you should be watching if you are completing the package that is meant to prepare you for science option for Sec 4. This video covers the questions number 39 to 42 specifically, and then whichever questions have to do with difference of squares in questions number 51 to 62. Okay, so a difference of squares is essentially a subtraction, so that's your difference, between two terms that are perfect squares. So in this example here, we have x squared minus 25. X being squared means that it is a perfect square, and 25, as we know, is also a perfect square. So before we get into exactly how to do it, because difference of squares is a rather simple method of factoring, I wanted to kind of look into the why it happens that way. So the first thing we're going to do here is actually factor this using our product and sum method that we do with trinomials. So what I'm going to do here is, as we know if you watch the product and sum videos, for product and sum you do have to use the kind of general rule of second degree equation. So we have ax squared plus bx plus c, and we need to have it in this format so that we can locate our a, locate our b, and locate our c. So a is always the coefficient of the x squared term. In this case, we have our x squared term. That's not a problem. I'm just going to write it over here. And we have our coefficient as 1. And then the b value is the coefficient of the x term. In this example, we don't have an x term, which means that b is 0. It's not here. There are no x terms, 0x. And then minus our 25, which is our c. So we actually do have an a, a b, and a c. I'm actually going to put this over here. So a is 1, b is 0, and c is negative 25. So this seems kind of weird because it's like, well, what are we going to do with 0? But it does end up working out, and you'll see how that plays out. So our first step for product and sum is to do the product. So we have a times c. A times c, in this case, is 1 times negative 25. So we end up with negative 25. Step 2 is to make our little factor umbrella have arraign factors from negative 25. We have 125, and we have 5 and 5. And our step 3 was looking at our b, right? So our b is 0, and our AC is negative 25. So that means that because this value is negative, we know that one of these is going to have to be negative and the other one is going to have to be positive. Since when I add them up, I will need to get 0, and when I multiply them, I will need to get a negative value of 25. So as we can see here, we have two 5s, which means that if I make one of them minus and the other one plus, then when we add them, they cancel each other out. They give us 0. Minus 5 plus 5 equals 0. And then if we multiply them, they give us a negative value. Negative 5 times positive 5 give us 25. So this is how we're going to break up our 0. So we are replacing 0 with 0. We're not changing anything here. Minus 5x plus 5x minus 25. So this right here, if I was to re-simplify this, it would cancel each other out and it would become 0. And now we can use our grouping method. So here in this first bracket, we can pull out an x value. We're left with x minus 5. And then in the second bracket, we can pull out a positive 5. And we will still be left with an x minus 5. And then we can rewrite this, x plus 5, x minus 5. So that's how we factor it using product and sum. And now just to go forwards, to re-expand this and to go through that in that direction. At this point, it's obvious what's going to happen. But just so that we're being thorough. So now I'm just re-expanding it. So we already got our factored answer, but I'm going the other way now. I'm expanding it out. And we'll see what makes difference of squares special. So I get x squared, I get minus 5x, and then I get plus 5x, and a negative 25. So here, when we go to simplify, these will always cancel out, and this will always happen. And that's why it is called a difference of squares, since that middle term will always cancel out if you have one that's positive and one that's negative. So the rule here is if you have any difference of squares of a squared minus b squared, you factor it as a plus b and a minus b. You don't actually have to go through the work here. This was just a demonstration. So this is really the rule for difference of squares. That's all it is. It gets difficult sometimes when the square is less obvious that it's a square. And we'll do 2 examples that are a little bit more challenging. Okay, so the next example is if we have something like this, 36x to the 4 minus 25 y to the 6. So the rule here is that we don't have to do any trinomials or product and sum or any of that. We really just have to set up, we see that it's a subtraction. You can't really see the squares in the exponents, but you can see the squares very easily in the coefficients. So it's easy to see that 36 is a square and that 25 is a square. It's not as obvious that x to the 4 and that y to the 6 are squares. But they are both divisible by 2. They're both even, which means that there is a square up there. If we remember our exponent laws, right? So power of a power. If we have x to the a to the power of b, then it becomes x to the power of a times b. If you have a power raised to another power, they do end up being multiplied. So we have to kind of reverse power of a power in this case to rewrite x to the power of 4 as a power of a power where the outside power is 2. So you really just need to divide it by 2. So here we're going to write 36. That's not a big deal. And then x to the power of 4, if we divide by 2, we get x to the 2, and then we put that square up there. 25. And a y to the 6. I should have given myself more space. 1 second. Put this here. 25, y to the 6. If we divide 6 by 2, we get y to the 3, all to the power of 2. So now, looking at it this way, it's quite more obvious that there are squares here. And so this is why exponent laws are so important, that stuff like this is not as obvious if you're not comfortable with your exponent laws. So now we can just do our difference of squares based on what we have here. So we put a minus, or we put a plus, and then we put a minus. And what we do is take the first term and put the square root, one there and one there. So put a little square root sign. So we square root our 36, we get 6. And we square root our x squared squared. So the square root will essentially cancel out that upper square, and we're left with x squared, x squared. And then we do the same thing on the other one. Square root and square root. So 25, square root of 25, that's 5. Square root of y3 squared is just y to the 3. So that is quite a challenging difference of squares. These types of difference of squares are not so common. I haven't dealt with this type of stuff very often. You'll find some difficult examples like this sprinkled throughout workbooks sometimes, but they don't come up as often. The ones that do come up very often are things that look like this. So we have 2x plus 1 squared minus 36. So this is a difference of squares. And this is really not obvious, because getting to the point where you can visualize something within brackets as its own kind of little unit you'll get there once you do a lot of algebra problems. But if I was to say that 2x plus 1 is equal to a, right? If I just called it a, then everything in these brackets here, I'm just going to replace with a. And if I had a squared minus 36, then suddenly it's very obvious. Yeah, that's obviously a difference of squares. It's a thing squared, and this is also a square. And then you can do difference of squares very simply with this. You have your plus and your minus, and then you square root the a, you put it in the front, you square root 36, and you put 6 at the back. But what was a? A was this. It was 2x plus 1. So I can now plug in 2x plus 1 in the space of a. 2x plus 1 plus 6, 2x plus 1 minus 6. And then this becomes a very different thing when you simplify it. It'll become 2x plus 7, 2x minus 5. And you don't have to do this whole a thing. The a thing was just to demonstrate that this is a difference of squares, but if you were to get something like this, you would go directly to your difference of squares. So you'd set up your brackets, sorry about that. You would set up more space in your brackets, because you will definitely need more space. But you set it up like this, and when you square root this whole piece, the only thing that goes away is that square on top. Square rooting all of this will cancel that little 2. And then what ends up going into each of these brackets is this piece, 2x plus 1. So you would just put in a little bracket here, 2x plus 1, 2x plus 1, and you'd get your plus 6 and your minus 6, and then go and simplify to the last step here. So you don't need to put the a and then substitute the a and all of that. That was just demonstration. So this is a much more complicated difference of square problem, and this comes up a lot. So next year, there will be these in a lot of places. Okay, so we'll do, I guess we'll just do 1 since they're all very similar. Okay, so having 16x squared minus 9, all we have to do, set up our brackets. The first has a plus, the second has a minus. Take our first piece, the square root of it goes into the front. Square root of 16 is 4, square root of x squared is just x. So 4x goes in the front, so both pieces. And then we look at 9, and the square root of 9 goes at the back. 3 and 3. And that's your answer, 4x plus 3 times 4x minus 3. Okay, so now that you know difference of squares, you might want to go back through the package to your factoring of trinomials, or not factoring of trinomials, to your grouping. Sorry. Some of these grouping questions over here, in the ones where you needed to factor out, where are my thoughts? There are some in the grouping in this section where when you did one step of factoring, you would be left with a difference of squares as the result of your grouping. So I suggest that you kind of just look back through your answers for this page up to question 38 and see if you have any results that look like this, that look like a square minus another square, because then that means that you will be able to actually factor them further using this method. Okay, so that is it for difference of squares. I will see you in the next video on perfect square trinomials. See you there.